Hello everyone, and welcome to the Neuron Club.
Today is all about receptors. When you think of receptors and how ligands bind, what do you think of?
Most of you probably have the picture of a lock and key where the ligand binds perfectly in a section of the receptor. We're here to tell you it's not that simple, sadly, in the body.
Today we will be focusing on norepinephrine, a catecholamine neurotransmitter, and its binding ability with the alpha-2A adrenergic receptor.
Alpha-2A adrenergic receptors are found in both the central and peripheral nervous system, located in both pre- and postsynaptic neurons. In the CNS, this receptor can regulate neurotransmitter release as an autoreceptor when located on adrenergic nerve terminals.
Alpha-2A receptors are a type of G protein coupled receptor which mediate their functions through a variety of G proteins including GI and GO, inducing a signal transduction pathway in the cell. Alpha-2A receptors have been shown to cause negative inhibition of adenylyl cyclase, resulting in the decrease of CAMP production. When you think of a GPCR, you imagine something like this.
In actuality, the 3D structure of the receptor is more complicated. We've 3D printed a model of the alpha-2A adrenergic receptor to aid in visualization.
The alpha-2A coupled receptor has 7 helices that wrap around and interact with one another to create the receptor. Binding of the norepinephrine involves helices 3 and 5 of the receptor. The binding involves interactions between the norepinephrine functional group and the specific residues of the receptor, primarily serine and the aspartic acid.
We first begin with the 7 helices surrounding a cylindrical space through the center. Once this binding occurs, a conformational shift in the receptor can be observed, which stabilizes the specific conformation of the receptor in order to activate its coupled G proteins. So instead of a lock and key model where there isn't a change in the receptor, the ligand binding triggers the receptor to move around into a different shape.